Hello. So my name again is Martin Wachia, and today I have decided to just go topical, and we are going to revise surds. Surds is one of the topics in Form 3 mathematics that is very common, especially in paper 2 of your KCSE. So today we are going to do surds, and we're going to just do a few examples of different ways in which questions in surds are set. And I'll therefore put my whiteboard on for us to start. I'll write most of the questions. These are past KCSE questions. So you'll allow me to just write here the questions. So the first question is rationalize the denominator and leave your answer in surd form. So surds. Yeah, it's not surd. Like it doesn't mean you can say it's not equal to surd. So it's just a form of happiness. In fact, it's one of the questions that most of the time appears in any logical mathematics exam. So here you have the first question. It says rationalize the denominator and leave your answer in surd form. In surd form. So I'll just write the first question before. This is the question, 3 over 2 root 5 minus root 2. Now, before I start solving this, there's a very important tool I would like you to know that you can use in solving surds. So, and these are quadratic identities. So just something for you to note. So you need to note, you can use quadratic identities to make your work easier and faster. So quadratic identities is also a common topic in Form 3. So the first identity is A minus B squared is equals to what? A minus 2AB plus B squared. The second identity is A plus B squared. This is squared, A squared plus 2AB plus B squared. When you expand them, then the last one, when you expand this last identity, that is A plus B, A minus B, you get A squared minus B squared. So this is going to be one of the most common use quadratic identities. So anytime you are dealing with surd, always remember this identity. A plus B times A minus B is just A squared plus B squared. So we can just go back and look at our question. So rationalize the denominator and leave your answer in surd form. So another very important thing to note is, let me just write your question there. It's 3 over 2 root 5 minus root 2. So this is a common question. And the first thing, you rationalize the denominator. And how do you rationalize the denominator? So you rationalize the denominator by multiplying it with its conjugate. By multiplying it with its conjugate. So you multiply it by its conjugate. Sorry, let me just write it clearly. Conjugate. So, and in this case now, we will have, so you multiply both the denominator and the numerator by the conjugate. So once you multiply anything in the denominator, you will also do it in the numerator. So this will be 3, 2 root 5 minus root 2. Its conjugate is 2 root 5. You change the sign plus root 2. That's the conjugate. Then times. So you also do the same in the numerator plus root 2. So you have the conjugate there. So when you solve the numerator, what do you get? So it's 3 times 2, that is 6 root 5 plus 3 times root 2, that is 3 root 2, everything over. Now you see here at the denominator, you apply, at the denominator, you apply the quadratic identity that we talked about, which is said that a plus b, a minus b is equals to a squared minus b squared. So our a squared, in this case, our a is 2 root 5. So in this case, it will be 2 root 5 squared minus b squared. Our b is root 2 squared. So 2 root 5 squared, that is 2 squared is 4 times root 5 squared. When you square root, it loses that sign. So that is just 5. So root 5 times root 5 is just 5, which is root of 25. Sorry, delete these. So that is that, minus root 2 squared, that is root 2 times root 2 is root 4. Root 4 is just 2. So 4 times 5 is 20. 20 minus 2 is 18. So that is over 18. So you see, you've solved your question. You've used identities to make your work. So you've used quadratic identities to make your work easier. So 6 root 5. Sorry, so we have had 6 root 5 plus 3 root 2 over 18. This looks like something that can be solved, can be simplified further, because this is 6 over 18 is just 1. 6 into 18 is 3. So 1 over 3 root 5 plus 3 into 18 is 1 over 6 root 2. So you've simplified your sum and you've left your answer in surd form. I just decided to start with a simple case. Let's do another example. Another example, number 2. So number 2 is still rationalize the denominator and simplify completely. So rationalize the denominator and simplify completely. So our question is 3 over 2 root 6. So this one we'll do a little bit faster. 2 root 6 plus 3. So 3 over 2 root 6 plus 3. Let's get to the solution. So the first step is multiply by the conjugate of the denominator. So this one, we multiply the numerator and the denominator by the conjugate of the denominator. So the conjugate of the denominator is 2 root 6 minus 3. Sorry, this is supposed to be root 3. Okay, let me just make that correction. Minus root 3 over the denominator will be 2 root 6 plus root 3 times 2 root 6 minus root 3. So you multiply it by the conjugate. Now, when you solve the numerator, that will be 3 times 2 is 6 root 6 minus 3 times root 3 is 3 root 3 over, so here you apply quadratic identities, which this times this is just what we've said, a squared minus b squared. So our a squared is 2 root 6 squared minus b squared, which is root 3 squared. So you go further, 6 root 6 minus 3 root 3. So this is 6 root 6 minus 3 root 3 over, what was the denominator? 2 root 6 squared, that is just 2 squared is 4. Root 6 squared is root 6 times root 6 is root 36. Square root of 36 is 6 minus root 3 squared, that is root 3 times root 3, that is square root of 9, which is 3. So 24 minus 3 is 21. So here the denominator is over 21. This can be simplified further because 3 is common to both. So 3 into 6 is 2, 3 into 21 is 7 root 6, minus 3 into 3 is 1, 3 into 21 is 7 root 3. So you have your answer in surd form. So let's see another example that takes a totally different shift. The question can come in so many ways. So this one is coming in a different way. So that is number 3. Evaluate by rationalizing the denominator and leaving your answer in surd form. So you evaluate by rationalizing the denominator and leaving your answer in surd form. Don't be tempted to use a calculator in these questions because, you know, candidates can become clever sometimes. Just do it by rationalizing the denominator. Sometimes you don't need your calculator, just solve this one. So it's root 8 over 1 plus cos 45 degrees. Now, this sum takes a different form that has angles. Now, if you see the angle 45, we need to write this as a surd. And this one takes us to remember very critical triangles in trigonometry. I will draw them down here. So there's the first triangle that is always, this is 2, 2, 2. So this is an isosceles triangle. Equilateral triangle. So equilateral triangle, this will be 60 degrees. This angle here will be 60 degrees. This here will be 1. This one will be 1. This angle is 90. So if this is divided equally, this will be 30 degrees, and this angle will be 30 degrees as well. So that is the first triangle. Then you have the second triangle. The second triangle looks like this is a right angled triangle, which is still an iso. So this is one, and it's right angle. So that means if these two sides are equal, this will be 45 degrees, and so will this side. So this side, of course, by Pythagoras theorem will be, so we know Pythagoras theorem said a squared plus b squared is equals to c squared. So our a squared is 1 squared plus 1 squared is equals to c squared. So c will be the square root of 1 plus 1, which is the square root of 2. So this is the square root of 2. So this is when you have 45 degrees, you need to have this triangle. So it's so important for you to remember this triangle. And now that we need 45 degrees, remember the two triangles. But in this example we are solving here right now, we only need the 45 degrees one. So I will just clear the rest of the board. So remember that those two triangles, they are very critical in your solution. So our question was 8. The root of 8 over 1 plus cos 45. So from here, cos, we know SOHCAHTOA. So from here, we know the cosine is adjacent over hypotenuse. So cos 45 degrees will be our adjacent. So pick any 45. Adjacent is this one. 1 over hypotenuse is root 2. Okay? So the adjacent of hypotenuse is root 2. Now here, so this will therefore be equal to root 8 over 1 plus 1 over root 2. So you have it like that. Then now you use rationalize the denominator. So it will be root 8 over 1 plus 1 over root 2. So multiply the denominator by its conjugate, 1 over root 2. Same to the numerator. Multiply by the conjugate of the denominator, which is 1 over root 2. So, this is equals to that. This one, of course, will be equal to root 8 times 1 is root 8. Root 8 times 1 over root 2 is root 8 over root 2. Of course, this one can be simplified to become root 4, but we shall show it in the next step. Denominator, apply, we said a plus b, a minus b is equals to a squared minus b squared. So our a squared is 1 squared, which is just 1. Our b squared is minus 1 over root 2 squared. So this is 1. 1 squared is 1. Root 2 squared is root 2 times root 2, which is root 4. The square root of 4 is 2. So it's just 1 over 2. So 1 minus a half is a half. So you have your value here as a half in the denominator. So you have solved your denominator here using a squared minus b squared. So something else you should note here is root 8 over root 2 is just the same as the square root of 8 over 2, which is the square root of 4, and that is 2. So you can write this equation, so it will be root 8 minus 2 over a half. So it will be root 8, sorry, that one, minus 2 over a half. So if you divide everything by a half, 1 divided by a half is just 2 root 8 minus 4. But sorry, root 8 can be simplified further by the, don't stop there, because, sorry, this one can be done better. Root 8 is just the same as root 4 times 2, which is the same as root 4 times root 2. So root 4 is 2. Root 2 is an irrational number, so you maintain it as a surd. So sorry, sorry for that. Let me just rub this step so that we include that. So our root 8 will be 2 root 2 minus 2 over a half. So divide everything by a half. 2 divided by a half is 4. You know, I hope you know 2 divided by a half is 2 times 2 over 1, which is 4. 4 minus, sorry, 4 root 2 minus 2 divided by a half is, of course, 4. And you have your answer there. So that is another way that the question can be set. So there are so many different ways in which these questions can be set. And these are previous KCSE questions. Then maybe the last one I'll do today is express the following in surd form and simplify by rationalizing the denominator. So let me just write it. I don't know which question is that. Should be 4. So express the following in surd form and simplify by rationalizing the denominator, and simplify by rationalizing the denominator. Now remember, here they give you a catch. Give your answer in the form. So they say give your answer. So this is a very important line because you must do that in the form A plus B root C. Very important instruction. So every time you're dealing with this question, you must look at this. This is a very important place. So they want you to give your answer in that form, A plus B root C. So our question is 1 over cos 60 degrees minus sine 45 degrees. So that's the question. Let's go ahead. So we said that one, there's 2 important triangles that we have said before in the previous question that you need to remember. So this one, this angle is 30, this angle is 30, this angle is 60. So this is an equilateral triangle. Here is 90. So this is 1, this is 1, this is 2, this is 2. So the height of this triangle, of course, will be, when we take the height of this triangle, it will be 2 squared minus 1 squared square root. So it will be square root of 2 squared minus 1 squared, which is the square root of what? 4 minus 1 square root of 3. So this will be root 3. Then another important triangle we've talked about previous is this one. 1, 1, root 2. I've just written because 45. So here we need cos 60. Cos 60 degrees is equals to, remember SOHCAHTOA? So cos 60, the adjacent of a hypotenuse. So it is 1 is adjacent of hypotenuse 2. So it's just a half. Then tan 45, sorry, sine 45 degrees. Cosine 60 sine 45 is opposite. Sine is opposite of hypotenuse. So this is 1 over root 2. So this is the adjacent of a hypotenuse here. Okay. So you have the two numbers. Now you can go back to your question. It was 1 over cos 60 degrees minus, sorry, let me just make it more presentable. The math is all about beauty of your presentation as well. It's so important. People must see cos 60 degrees minus sine 45 degrees. So this one becomes what? Sorry, So this one becomes cos 60. We said it's a half. Any candidate should know cos 60 of head. Simple. Then cos 45, sine 45 is 1 over root 2. 1 over root 2. So the next step is to rationalize. And you rationalize by multiplying both the numerator and denominator by the conjugate of the denominator. So rationalize. It's 1 into a half minus 1 over root 2 over a half minus 1 over root 2. Oh, sorry, plus. That's the conjugate should be the opposite sign. A half plus 1 over root 2. So that's the conjugate. Then this one, of course, becomes, I don't want to go to another page. Let me just try to squeeze it here. So the numerator will have a half plus 1 times 1 over root 2 is just 1 over root 2 over, let's just move to the next page. So the numerator is 1 times a half is a half. 1 times 1 over root 2 is 1 over root 2. So it will be a half minus 1 over root 2. Is it minus? It's plus. Over the denominator is a half. So it's m. It's in the form a. It's in the form a minus b. So let's just remind ourselves again. It's in the form a minus b, a plus b, which is gives us a squared plus, sorry, minus b squared. A squared minus b squared. Okay. So, and in this case, our a squared is a half squared. Sorry for doing a lot of dirty work on the work. Minus b squared is minus 1 over root 2 squared. So a half squared is a quarter. 1 over root 2 squared is what? Is 1 over root 4 which is 1 over 2. So when you square a square root, you just remove the sign, easy, like that. Or, you know, something you need to remember by the, it's not that you remove the sign. A half squared, square root is just the same as putting something to power a half. Always remember that. Then times 2. So that is 2 to power a half times 2. That's how it becomes 2 to power 1. So that's how it, so a half minus a quarter, that is negative a quarter. So the denominator will be negative a quarter over negative a quarter. So remember, the answer is needed in the form a plus b root c. So divide a half by negative a quarter. It will be times negative 4 over 1. Here is 1, here is 2. So this will be negative 2. Then 1 over root 2. Divide by negative a quarter. It will be times the reciprocal, 4 over 1. So that will be negative 4 over root 2. So it will be minus 4 over root 2. So you have your values. So in this case, your A is negative 2. In that case, your A is negative 2, and your B is negative 4. Your B is negative 4, and your C is so your C is, oh, sorry. We are not done, my people. We are not done. So your answer must look exactly like what we have there. So we are not really done. I would probably write this answer eventually. I hope to make it look like how they want. So our A is negative 2 minus B, of course, B is minus 4. C is 1 over 2. This is just the same as root 1 over root 2, because the square root of 1 is 1, so it's just 1 over root 2. So you can write it like that. This is the final answer now in the right format. So I want to appreciate you for paying attention. Subscribe to my channel, like, comment, share, ask questions. I will respond. Have a nice time. Next time we'll do another topic. Thank you for your time.